Hi, my name's Keith Fredericks. My company is Rest Frame Labs. We're just relocating back to New York right now as we speak. First, I'd like to start with just a bit of history. I started out in 1979, and in my research darkroom at Rochester Institute of Technology, we were experimenting with photon amplification of photographic emulsions, and what I found was these interesting tracks. And so let me go through some of the tracks I've found over the years. Top is what I call a random motion type track. The middle one is what's commonly called a tire track or a caterpillar type track. And the third one represents a very long track at 69 millimeters. This is one of the first exposures that I found that indicated some kind of central force operative. You can see a lot of different correlated tracks on this exposure, and it's very difficult to analyze, but there is a central force active here. And then here's an exposure from 2014 that I call Cyclone, and there's clearly a central force active here. Now, some of the other history. During ICCF11, and I believe in 2004, Ritskoyev, Ivoilov, and Loshak from the theoretical side presented regarding strange radiation. At ICCF18, I presented really the idea that the same tracks can be obtained with a simplified technique, not via electrolysis or a high energy discharge or a low energy discharge, but by simple uniform photon exposure to film in the darkroom. And the source is unknown, but I assume it to be ambient or cosmic. The main question after 2013 that I had is it possible to get replicated, reliable magnetic or electric curvature for these particles with applied fields? In 2014 in Norway, this is the first elliptical track that I found. And it's extremely interesting because when I measured this, this corresponds to, the track is, the semi-major axis size of this track is 137 squared n squared different from a Bohr-Sommerfeld electron of n equals 7. And so what this does is it brings up the idea of the magnetic to the electric force, which is 137 squared n squared, and this makes you think about the possibility of magnetic monopoles. But the first thing I really needed to do at this point is figure out, well, can this be replicated? So I went on about to try to replicate this stuff and furthermore to analyze it. On the left, you see the ellipse fitted to the track. B is after processing and background eradication, and then C is the original photo from the microscope of the track. And this is this particular one is an n equals 5.0 track. Here's an n equals 2.75 track, and the interesting thing about this one is the big dark track underneath connected with the ellipse above it. This is the detail of that same track. And again, all of these tracks are excellent fits to ellipses. This is an n=8 track, and unfortunately I don't have the movie because of this is a PDF instead of a PowerPoint presentation, but nonetheless we see a very large size difference all the way from n=8 down to below n=2 or n=3. And this was supposed to be a detailed movie so that you can see the structure and the goodness of fit of these tracks, but unfortunately we don't have the movie. And finally, this exposure shows what I believe is one of the key things that I observed with this, and that is the idea of either splitting or decay associated with the ellipses. And you can see the particle track traveling along, and the ellipse seems to split from the main track and then become captured into the elliptical orbit. Plotting the 22 ellipses that made the cut out of the 750 exposures that I did, we find that the ellipses are quantized by half integer values from 8.0 down to about 3.5, and then further by quarter integer values from 3.5 on down. Now to recap so far, I found no observed curvature effects due to applied electric or magnetic fields whatsoever. Nothing replicatable. And that is within the field strength that I applied. I found some sort of decay events, often associated with these elliptical tracks. The ellipses must be bound states caused by an inverse square central force. And the elliptical tracks are 137 squared n squared bigger than Bohr-Sommerfeld hydrogen. This is an illustration of what I think may be happening with these tracks. You see at P1, a particle is incoming at point A. It appears to split or decay into a particle that continues on with P1 prime, almost in the same direction, and another particle then that appears to be captured into an elliptical orbit until point B, where it exits the elliptical orbit. Here's with the magnetic charge equal to 2 GD, which is the Dirac magnetic charge, or this is also known as the Schwinger charge. The ratio of the magnetic force to electric force is 137 squared n squared, and that's why this is interesting. In 1983, Timur Datta discovered a new relation by applying the Dirac quantization condition and analogy with the electron. He found that there is a trio of fundamental lengths that appears to mirror the electron fundamental lengths, the Bohr radius, the Compton radius, and the classical electron radius as a set of monopole lengths. I found this to be interesting because it appears to map to the idea of extended relativity, which is really the study, the classical theory of tachyons. In Datta's work, he was using the analogy with the electron, and what he found by matching up the Bohr radius for the monopole with the ground state orbital velocity of the monopole, in this equation he found c over alpha, which is superluminal. At that point, Datta decided to discontinue his work on this, and he said it's unphysical, and that's why monopoles don't exist. However, I was interested in the idea of the structure, the architecture, and how this new structure that comes out if you use G equals 2GD, where this maps one-to-one with the idea of extended relativity. And so here are the 7 now fundamental lengths. You get both the mirrored hierarchy above the velocity equals the speed of light, and you also get this new length d, which maybe is a new kind of fundamental length that corresponds with the speed of light. And then what you can do is you can match these up with the ground state orbital velocities of the monopole and the electron and the speed of light. And then you get a bigger table with velocity on the left and length on the right. And to map this one-to-one with extended relativity, I use George Sudarshan's original designation of type 1, type 2, and type 3 particles, being slower than light, light speed, and faster than light particles. But we see, and we'll come back to this later, that this is interesting because you have this corresponding relation with respect to length and not velocity. Extended relativity is basically, as I was saying, V less than C, V equals C, and V greater than C particles, or more generally, type 1, type 2, and type 3 frames in the special relativity sense. Extended relativity says that there's a symmetry between the type 1 and the type 3 particles, slower than light and faster than light. Type 3 electrons are monopoles in a type 1 frame. And this is something that Parker came up with in 1969 and this was really the advent of applying relativity to faster than light particles. And the superluminal Lorentz transformation connects type 1 observers with type 3 objects. So in order to figure out what these objects are, we need to have some kind of transformation to transform them back into our reference frame. And so that's superluminal Lorentz transformation. But there's a problem because the 4D superluminal Lorentz transformation yields imaginary quantities. And this was a problem for extended relativity for forever, and it still is a huge problem. There was some work done with 6-dimensional spaces on this to solve this problem, but it was not entirely satisfying. So if we do a superluminal Lorentz transformation on an ellipse, this is what happens. It comes out as a dual cone structure, which really looks nothing like an ellipse. And this is the standard superluminal Lorentz transformation of an ellipse. So the detected tracks, the tracks that I detected, and the Bohr-Sommerfeld ellipses have the same exact eccentricity. And, as we've just seen, the SLT doesn't really work in this sense. We should be seeing a transformed ellipse that actually looks like an ellipse. And so we need an isotropic scale transformation to appropriately transform between the type 3 and the type 1 frames. And this is it. This is the Coulomb flip, and this is how a type 1 observer sees a type 1 electron orbit and a type 3 monopole orbit. And the Coulomb flip transforms the electron into the monopole. Here are the modifications that are required to extended relativity to bring it into line with the experiments. Charge equivalence, originally proposed to be magnetic charge equals the electron charge times the speed of light, becomes the Schwinger quantization condition, which is G equals EC over alpha, which is also a Coulomb flip. The coupling constant, alpha, fine structure constant, becomes alpha if it's slower than light and 1 over alpha if it's faster than light. The transformation factor from type 1 to type 3 frames in extended relativity is simply gamma. This is the superluminal gamma. And in the new formulation, it's alpha squared. Now let's take another look at this table. And it's interesting to note that the quantities on the left-hand side, velocity, which align with the quantities on the right-hand side of length, are the comparison of a vector type quantity versus a radius quantity. And the radius are specifically talking about the radius of spheres, as in the Bohr radius, Compton radius, and classical electron radius. And relativistic transformations, comparing the motion to length-based transformations, this is just an interesting thing. And I've never seen this before. It's an interesting thing. V over C equals L over D. And so beta equals big alpha. The superluminal gamma is equivalent to the alpha. And the relativistic scale transformations then become substituting a squared, 1 over a squared minus 1 for alpha squared. For the Coulomb flip, relativistic mass becomes this relativistic expression. Schwinger quantization condition, interestingly, can become a relativistic expression as well. So here to summarize, what we found in the research coming out initially from the experiments that were done. We found 7 fundamental lengths. We found that a scale transformation is necessary between type 1 and type 3 frames. We found the possibility of changing the equivalence of charge from extended relativity to a new model. We found possibly a relativistic foundation for the Dirac-Schwinger quantization condition. And indeed, if these are the equivalent of magnetic monopoles, then we have found a cause of charge quantization. And finally, it's interesting that this likely solves what is known as the imaginary quantities problem in the classical theory of tachyons. So, the model makes progress in the classical theory of tachyons, and through the scale transformation brings an entirely new view of the study of faster-than-light objects. Using this model, the elliptical tracks can be characterized as plane-bound electrons from a type 3 frame, or otherwise as 137 squared magnification of electron orbits. This is, of course, of interest because quantum mechanics itself was born out of old quantum theory as a result of not being able to see orbits. Okay, here's the paper, if anyone is interested, and that's it.
Thank you. I would like to commend you on the experimental work. I think it's really great and very important results. And I have, if you don't mind, a suggestion for simplifying the theory. Because I mentioned yesterday that we are working on Maxwell's equations, and well, in this book we describe what we believe is the proper Maxwell equation in space-time relativity, and that includes the solutions for magnetic charges and magnetic currents. So actually we do have the Maxwell equation that shows you how to solve magnetic monopoles, and you don't need superluminal velocity. You can just work with normal relativity. And what is interesting, when you look at the scales of nature, I showed yesterday that you have the electron charge, and you multiply it by, which is electric, you multiply it by 137, you have the magnetic Zitterbewegung, again by 137 you have the electric Bohr orbit. So this is a pattern that occurs on nature, and I think it may help you to study Maxwell equation. And the other comment I have is about the work of Mikhailov's. Are you familiar by any chance by Mikhailov's work?
Yes. Yes.
Because to me that was really interesting to see their results. They were the first ones who experimentally quantized the magnetic charge, and their results very much correspond to your results. And I think everybody should try to get Mikhailov's results, which I think almost nobody knows, unfortunately. But they measured, besides this 137 square factor that you have, also a factor of 1/3. And that's a question where that factor 1/3 is coming from.
Yeah, thank you.
So you're in business already. Please.
Just a comment. Based on pure speculation, I came to the conclusion the translational velocity of the particle shouldn't be bigger than the speed of light. However, the rotational tangential velocity, I came to the same result, should be c over alpha. It's in the poster presentation. So it's very much in line what you're telling.
Okay, maybe we can talk further about this.